Hey guys, this is Sarah back with my next lesson and new setup. So I hope you guys will like this. So today's lesson is 8-1. We have done derivatives so far from this section. Now it's about taking integrals. So integral of exponential functions. Alright, so just the way we always do it in class. So first I'm going to show you derivative and we'll figure out the pattern and then we'll do integral from there. So here's the derivative on this side and integral on the right side. Let me pick a different color, so why not? Let's just try different things. Here you go, let's pick red. So derivative. If you take derivative of e function, it's always equal to the function itself, which is e to the x. Now, since integral is just opposite of derivative, so it means if I take integral of e function, it's going to be equal to e to the x, which is the same function, and we'll just add a constant at the end. Here you go. So that's how we do integral of exponential functions. So I'll show you a few examples. If you want to follow along, you can go to page number 514, and this is example number 5. So here comes the first one. I have integral of e to 3x plus 1 and dx. So first, today's focus will be just on pattern recognition. So it's on pattern recognition. Gosh, it's pretty cool writing with this pen. So let's pick a different color. Let's just do white this time. Let's see how it goes. Okay, now pattern recognition. The way, no, that's not a pen. So let's pick yellow. No, I guess I have to pick this pen first, then the color. Now it makes sense. Here you go. So here comes, so pattern recognition. So I know if I take integral of this piece, I know this original function would stay the same, but it should have derivative of this part attached to it. Okay, I know derivative of 3x plus 1 is equal to 3. Which is not there. So I hope you remember, in order to complete the pattern, what you have to do is you just have to bring in the number. So I know this 3x plus 1 is my original problem. It should have 3 in the equation to complete the pattern. It's not in there, so it means I have to bring in the number. You can't just bring in 1, 3. You have to do 3 over 3 because technically it's equal to 1. If I do that, so this top 3 would complete the pattern. So this 1/3 is just extra number. So just pull out the constant, which is 1/3. So I have 3x plus 1 times it by 3 left, which completes the pattern. So now integral of this function would be 1/3. And you know, integral of e function, this 3 just completes the pattern. So it's just going to go away. So your original equation is going to be just this function with 1/3 and add c. And here's my answer. All right. It's okay. I'm going to show you one more example. I hope that will make more sense to you. Okay. So example number 6. Example number 6. Let's pick a different color. So I'm back to, let's pick school color. Here you go. Purple. Good one. All right. So I have integral of 5x e negative x to the second. Okay, let's try identifying the original function first. So I know my original function definitely going to be this e function. So this e function should have derivative of this x squared with it. So let's just find the derivative of negative x squared first. Okay, derivative of negative x squared would be negative 2x. So it means this function should have negative 2x attached to it. So let's say, oh, I already see x in this equation. I'm sorry. But this 5 is not needed. So what I could do is, just to make it easier, I'm just going to pull out the constant first. So now my new equation would look something like this. Okay. So what's needed? Now let's figure out what's missing, and I'll just bring in the number. So what missing is negative 2. So I can just bring, let's pick So I would bring in -2 over -2. So this top -2 would complete the pattern. I can factor out -1/2. So after factoring out -1/2, this would become 5 over -2. This completes the pattern. So it means this completes the pattern. So it means my original equation would just be this. Let me just rewrite this just like this. And finally, my answer would be 5 over -2. Now let's take integral. So that would be just the function itself with e and a, and then I would just add c at the end. Here you go. All right, I hope this makes sense to you guys. Let's look at another example. So today my focus is just to show you on pattern recognition, and then tomorrow I'll show you use substitution just in case you want to try that. So let me show you one more example. This is example number 7. It's part A. I know it might gonna look scary, but trust me, it's pretty simple. So I have e to 1 over x squared, and it's dx. So first thing, I know this e function, which is this piece, definitely going to be my original equation. But okay, now I need to make sure, is the other part derivative of that exponent or not? Okay, let's just take the derivative of 1 over x. Just in case, we'll have everything handy. Okay, so derivative of 1 over x, I hope you remember, you can take it to the top. This becomes -2. Now derivative of x to the -2. All right, I'll bring this over. So this is -2 x2. Oh, my bad. I'm sorry. Messed up. Oh, gosh. I'm sorry. I'll just erase this whole thing. Because why this is -2? That's not right. My bad. Back to my pencil, and let's rewrite. This is the part I need to take derivative of. If I take derivative, so I would bring this over. This is -x, and then -1. This becomes -2. If I do that, simplify, this is -1 over x to the second. So it means, if I look back to this example, it should have e function with this derivative. Do I have that? So let's check that. So I can even separate that, just to kind of see every single part of this equation. So this is what I have for my original equation. Let's just write it into 2 different expressions so that I can see what I have in there. So this is my original equation. Is this derivative of that exponent or not? Yes, it is almost there, but something is missing. So what is that missing? There's -1 that's missing. So bring that in. So I would keep e to 1 over x. 1 over x squared would stay the same. Now let's bring in whatever is missing. So -1 over -1 will complete the pattern. So, and then I'll factor out extra -1. So I could do 1 over 1 is still going to be the same thing. Either you put negative with the top or bottom, is still going to be the same thing. So now this whole thing and this would complete the pattern. So my function would be e to 1 over x and plus c. And at the end, I'll just simplify more. So this would become -e to 1 over x plus c. Here you go. So that's all. So I hope you guys enjoyed this new setup. So feedback, please. I really appreciate if you could actually tell me anything else I could do to make this better. And this is all. So stay safe, and I hope to see you guys soon. Yeah, I miss you guys a lot. Anyways, if you have any question, you can send me a comment, and I can just answer that question. Thank you guys. Thank you for watching. Bye-bye.